Welcome for this mathematics lesson. We're going to discuss loci, number 19. Part A, using a ruler and a pair of compasses only, construct triangle ABC in which AB equals to 8 centimeters, AC equals to 8 centimeters, and angle BAC is equivalent to 60 degrees for 2 marks. Let's begin with that. I'm going to interpret the other instructions as we continue. I'll begin by doing this triangle. Begin by doing the triangle. The length AB is equivalent to 8 centimeters. So I'll begin by a very straight line. Very straight line. Then I mark point A. Then now I'll use my compass to measure the distance of 8 centimeters. This is exactly 8 centimeters. So now I will need to stand at A. Then along the straight line I make an arc. This arc is going to take me to my point B. 8 centimeters. Again, we're supposed to know that the distance from A to C is equivalent to 8 centimeters. And again, the angle BA to C is equal to 60. According to the instructions here, we have the 8 centimeters and the 60 degrees. So they can be constructed, but I'll begin with the degrees. The 60 degrees. We've been told using a ruler and a pair of compasses only. That means we will construct and not measure the 60. So standing here, I just need to make an arc. Then standing on the other side, now I'll cut that arc. That is going to give us a measure of 60. Yes. So now if I produce a line through that arc, I'll have constructed 60 degrees at point A. I'll have constructed 60 degrees at point A. Now I need again to measure the 8 centimeters. The 8 centimeters. So 8 centimeters again, because AC is also 8 centimeters. So I measure 8 centimeters. Yes, that is exactly 8 centimeters. So standing at A, I make an arc. That is going to give me now my point C. It's going to give me my point C. This is going to be 8 centimeters. When I connect B and C now, B and C, I will have the best triangle. So this is triangle ABC constructed already constructed. Let me go to the next instruction. After that, we have been told to determine the locus L1 of points equidistant from A and B. It's good to know how to define this loci or this locus from A and B. These are two fixed points. Now, a locus of points equidistant from two fixed points is a perpendicular bisector of the line joining A and B. So if A and B are two fixed points, a locus of points equidistant from the 2 points is a perpendicular bisector of the line connecting A and B. Therefore, I will perpendicularly bisect A and B. Perpendicularly, I should bisect A and B. So standing at A, I should just make an arc at this point, and I also make an arc at this point, so that now standing at B, I cut that particular arc. So I stand at B and I make an arc to cut the first one, and also on the other side so that when I connect now, when I connect the two arcs, when I connect the two arcs, I'll be having my locus. I'll be having my locus. This is the desired locus. The locus of points equidistant from A and B is points lying on this point now. Points lying on this perpendicular will be equidistant from A and B. So that is the locus, L1. Part B is done. We go to part C, whereby we are determining the locus of L2 of points equidistant from AC and AB. As we can see, AC and AB are two lines. Now, a locus of points equidistant from the two lines means that the two lines are meeting somewhere to make an angle. Now, a bisector of that angle where AC and BC meet is going to be the locus of points which are equidistant from the two lines. So points equidistant from AC and AB are the points which lie on the bisector of the angle here, which is 60 degrees. So for me to bisect the 60 degrees, I simply need to stand at this point. I make an arc. Then standing at this point, I cut the arc. I cut the arc. Therefore now I can produce a bisector of the angle. So from 60, I pass through this point. I'll have bisected the angle. So I have bisected this angle, and this becomes the locus of points equidistant from the two lines, the locus L2. So that one is obtained. We go to the next. We are told in part D now to determine the locus P of points such that angle APB equals to 140. Angle APB equals to 140. That is what I will be working out, 140. Now this angle is an obtuse angle. It's an obtuse angle, and we have to know how to construct such a locus. Okay, this is automatically the constant angle locus, but now we should know, if the angle was acute, we would have constructed a point to be the center for the constant angle such that the point is double that angle. But in this case now, we need the locus of points such that when we pass through A and C, at any point we can project 140. At any point we can produce 140, so that the locus becomes this portion of the circle. Any point we can project 140 using AB, then that will be our P. But now, because we've known this is 140, then we should know and tell ourselves that there must be then, because this is one circle, if this is 140, now taking this contralateral as cyclic because all the vertices are on the circle, then we will need a 40 degrees here. That is according to the angle properties of circles. Opposite angles in a cyclic contralateral are supplementary. So this is a 40 degrees. Now we can work with the 40 degrees such that for us to produce 40 degrees at this circumference, there must be a center where double this angle is produced. Again, angle properties of a circle. It means this circle as a center where for 40 to be produced here, then there must be an 80 at that point. So there must be 80 degrees here for 40 degrees to be subtended at the circumference. Again, it means that if this is 80, then we should be having base angles of 50 and 50 here. So that 50 and 50, then 80, we complete the triangle. Therefore, I'll measure 50 and 50 so that I get my 80, and getting the 80 will guide me to obtain the center so that I may deal with the circle now. So I'm going to measure 50 degrees and 50 degrees at the 2 points. So standing at B, I'll need to produce 50 degrees. So from 0, this is where 50 degrees is. So I'll need to draw that 50 degrees. That is the 50 degrees. This is 50 degrees. That means I also stand at point A and I measure the same 50 degrees. Therefore, this is from 0 yes. So from 0, this is a 50. That is 50. So I need to produce that 50. This is also 50 degrees. Now, with 50 and 50, it means there is an automatic 80 degrees at this point. There is an automatic 80 degrees at that point. This is now what I wanted. This is what exactly I wanted. This is exactly what I wanted. So that with 50 degrees, now if I use this as the center, it means there is a circle whereby 40 can be produced, so that we will have 140 on the other side. So standing at this point of intersection and using it as the center, that point of intersection, then with point A and B, I can now produce a circle. Just stand there. Yes, so I have produced my circle. Such that this is 80 degrees. It means anywhere on the circle on this side, using AB, I will produce 40 degrees. I have the angle at the center. I'll be able to produce 40 degrees. Now that I will produce 40 degrees at any point here, just trying to illustrate how we are going to arrive at 140 degrees. Now that using AB, now that this is 80, using AB, any angle at this point, is going to be half the angle at the center. That means 40 degrees. Now with 40 degrees here, on the other side of the circle now, whereby using AB, we are able to produce 140 at this point, and using B, so this is going to be 140. So anywhere along the arc which is above line AB, is going to be the locus of P. The locus P, because we can produce 140 degrees anywhere there. 140 degrees, because 140 and 40 are opposite angles in a cyclic quantilateral. So we are able to get our 140 degrees anywhere along the arc. Anywhere along the arc. So this is the locus that we wanted. The angle there is 140. The next is determine the locus Q of points such that CQ equals to 5. So CQ is from C to Q 5 centimeters. These are locus of points which are at a fixed distance from a certain point. So Q is 5 centimeters away from C. That should be a circle using C as the center. So using C as the center and a radius of 5 centimeters, we are going to get the locus of points which are 5 centimeters, and that will be the locus Q. So I will need to use my ruler and my compass to lift a radius of 5 centimeters. Then standing at C, I make a circle. Standing at C, I do a circle. I'm going to construct a circle. Yes, I construct a circle like that. Now, with that circle, because the radius was 5, anywhere along the circle is the locus of Q, because from C to any point on the circle, I'm using a distance of 5 centimeters. So that is the locus of Q. That is the locus of Q. Then finally, to wind up the question, we've been told that a point W moves inside the triangle such that L1 is greater than AL1 is greater than BL1. So we have AL1 and BL1, that AL1 is greater. That means if AL1 is greater, then we need the other side of this locus. We also told that angle BAL2 is greater than CAL2. So we need such that now the angle, we are dealing with these two angles now, that the angle on this side is greater than this, and that means we need the other side. So I'm shading for this locus that side, but for this one I'm shading this side, so that BAL2 is greater than CAL2. So for this locus I'm shading the inner side, but for this one the outer side. Then again we are also going to have such that CQ is greater than or equal to 5. CQ to be greater than 5 means now CQ to be greater than 5 means beyond. Greater than 5 means beyond the circle here. Greater than 5, because within the circle is less than 5. Greater than 5 is outside the circle. So this is then required. The region is here. Therefore now, for us to shade such a region, because it is region W, we're going to shade it in this way. I've said this side of locus 1, AL1 is greater than BL1. Therefore, we require this side. This is the part we require. And also for this line, We have said angle BAL2 is greater at this point, but now we require the side which is less, so we require this side. So it means we're going to shade this region inside the circle, and also the region must also be such that QC is greater than 5, which means from the circle we need the inner side, and because the required one is going to be shaded, now it means we're going to shade this region. We're going to shade this region now. This is the region to be shaded. That is the region to be. This is our region W. This is where region W is going to be. That is our region W. Region W. So the shaded with blue is the one meeting the requirements described there. Thank you for following. Subscribe and share.